Good morning, colleagues. I'd like to tell you or discuss the threat of migratory and invasive insect pests to food security in South Africa. First of all, I'll discuss locusts, which are legislated and notifiable pests in South Africa. Since about 1911, the locusts were the first pests to be legislated in the new the Union of South African Government. In South Africa, we have 4 species. We have the brown locust, the red locust, the African migratory locust, and the southern African desert locust. This one is a subspecies of our more infamous North African desert locust. Other serious invasive pests are the African armyworm, the fall armyworm, which has been in the news a lot lately, tomato leaf miner, which is also a nasty pest indeed, the oriental fruit fly, and apart from these pests, we've got a plethora of other invasive and migratory pests that impact food security and crop production, from quail birds to we've got 400 species of invasive alien plants, for example. The impact of pest invasions on farmers. Well, first of all, obviously, there's a yield loss, and this is a direct economic loss to the farmer. He has to control the pests at farm level, and this is the cost of preventative or reactive management. And all these pest management inputs means additional costs and less profit. So eventually our farming becomes less and less profitable compared to competitors in other parts of the world. The commercial farmers, generally, they have larger farms, high value crops, but they also have high costs of crop protection. Most of them have access to modern pesticides and application techniques, and more are using GM crops. And critically, they have access to technical information and specialist advice. This can be given by the agrochemical industry, as they've got a very good support network, but they have access to computers and they can find advice if they need it. This is compared to the smallholder farmers, who generally have smaller farm sizes and are very vulnerable to complete crop loss. They usually have lower yields and relatively high input costs, such as fuel, seeds, fertilizers, and whatever. As a general observation, they have poor access to technical advice. They have poor access to registered pesticides and technologies. Their resilience to agricultural risks is low. They're vulnerable to pests, drought, and economic shocks. To millions of smallholder farmers and subsistence farmers across Africa, the invasive and migratory pests are the last straw for their farming endeavors. The brown locust. Let me talk about the locust first. The brown locust is our most economically important locust. It has an outbreak area in a semi-arid Karoo. You have a high fecundity and high outbreak frequency. Over the last 100 years, I've worked out there's over 9 out of every 10 years we've had outbreaks of somewhere or other in the Karoo. This is gregarious outbreaks that needed control. Swarms escaping from the Karoo can invade the entire southern African region, and there's a huge threat to food security. The outbreak area, as I mentioned, is in the semi-arid Karoo, but before modern pesticides became available after about World War II, swarms used to run rampage throughout southern Africa, right the way to the Zambezi River. So food security was a major threat, threatened throughout the region, and locusts were the #1 pests for all governments. Here's some photos of the thousands and thousands of hopper bands and swarms that develop in the Karoo. Most of the hopper bands are relatively small, about 20 meters by 30 meters. In these remote areas in Bushman land and the upper Karoo, some of the hopper bands can get quite large, up to about 1/4 of a hectare in size, and extremely dense. This is roosting at night, and then this is taken in the early morning. This is thousands and thousands of hoppers per square meter. During the day, they march in long columns, stretching out for kilometers. They can walk about 2 or 3 kilometers per day, so they can soon trek off farms. Then they form the swarms, and this is a roosting swarm early morning. The average size swarm is about 14 hectares, but I've seen plenty of swarms that have been 2 or 3 square kilometers in extent. And we have thousands of these targets. The Department of Agriculture chases around and locates these targets and sprays them early morning. So they go out in their buckies and they look for these targets and they spray them. The outbreak frequency of the brown locust, I went back in through the literature and the government reports all the way back to the 1940s, and this is the number of magisterial districts where locusts were chemically controlled. So this is outbreaks in magisterial districts. And you can see the clear outbreak patterns of the brown locust over the last 60 years or so. And that was up until 2005. Massive outbreaks in the 1950s, early 70s, and a big, very big one in 85. In 1985, we worked out the locusts invaded 88 magisterial districts. There were 175,000 hopper bands controlled in South Africa and 40,000 swarms. So this is a massive problem. And as you see from the very few years when there's no outbreaks recorded at all. So it's a perennial problem. We have other locust species. We have the African migratory locust, been causing a lot of trouble recently in the cropland areas in southern Zambia, and southern Zimbabwe, and in Angola. We have outbreaks in the Free State and Northwest provinces in the maize and sorghum crops and wheat crops in winter. Can cause a major issue if it's not carefully looked after. And because it lives in the crops, it causes direct damage to crops. Other species are the red locust, which has its outbreak areas in Central and Eastern Africa. We're in the invasion area. We do have lots of red locusts living here, but they don't breed here. Don't breed as gregarious hopper bands. But we are in the invasion area. Massive problem. And there's our Southern African desert locust. Has outbreaks in the Kalahari north of Uppington, but only on a very small scale compared to the massive problems of the North African desert locust. This is a photo of what locusts can do. This was a red locust swarm over Braamfontein in the 30s. Unless we get our act together and manage locusts properly, this is the situation that's going to occur again. Locusts were running rampage throughout the Southern African region. Other migratory pests I'll talk about are the African armyworm, the commando worm as they call it here. It's an invasive pest. About once every decade we have a large outbreak, but smaller outbreaks every 3 or 4 years. The caterpillars crawl along the ground. They're black in color and they march across the crops. I took this picture from the internet, a classic photo of African armyworm damage to maize in Lesotho. It was attributed to the fall armyworm, but it's not. It's African armyworm. And when they get into crops like this, they can cause immense damage. I've personally seen hundreds of square hectares of veld grass completely denuded in the Northwest province, north of Vryburg. Kilometers and kilometers of grass just gone. And it's too expensive to control over those vast areas. The fall armyworm has been in the news a lot lately. First outbreaks were in West Africa in 2016. This originated from the Americas, from the Central Americas, got into West Africa somehow, we're not sure. Soon established and soon spread throughout Africa.
Roger, the slides aren't moving.
Invaded Southern Africa in the January 2017. It's now well established in the warmer areas of the country. So severe.
Roger?
Yes?
Roger, sorry for the interruption. The slides are not moving along. Are you on the fall armyworm slide now?
Yes, that's the fall armyworm slide. Yes, I'm talking, yeah.
I can see the fall armyworm slide.
Yeah.
Okay, colleagues, then I think, yeah, so we're on the slide that says fall armyworm signs of infestation and damage. Can everyone see that? Yancy, can you just respond? Can you see that?
Yes, I can see that.
Yes.
Okay, then we're fine. Sorry for that, Roger.
No problem. So just talking about the fall armyworm, the recent pest, now become a very serious pest of maize. Here's a picture taken by Deirdre Visser at ARC of the young instars causing the windowing effect on maize. And then the neonates, they dangle on threads, on silk threads. And this is how they distribute themselves between the maize plants in the field. So very soon, all the maize plants can become infested by fall armyworm. And then compared to other stem borers, this fall armyworm damages the growth points, completely eats out the growth points. So it can cause immense damage very quickly to maize. The ARC was funded by the Department of Agriculture, Dillard and Jan Hendricks Group, to look at the overwintering of places where the fall armyworm overwinters. This is now an endemic pest in South Africa. It's not an invasive pest anymore. It's here to stay. During the summer, it can invade the maize grain basket on the Highveld in the Free State and Northwest provinces, but in the winter, the frost kills it off and it retreats to these refugia areas. And in the smallholder farming areas who rely on maize for food supply and income. And here they grow maize year-round often. And the fall armyworm is now endemic in these areas, and this is causing these foci for future infestations in the summer. The green dots were surveys in 2019, and the red dots were surveys in 2020. The commercial farmers are largely protected by their BT maize varieties, but we are seeing damage to single BT genes varieties, but the multi-stack are giving good protection so far. Again, the department funded the ARC, and we did a socio-economic study of the impact of fall armyworm in smallholder farmers in Limpopo province. The Limpopo provincial authorities said that there was approximately 3,500 smallholder farmers impacted on 40,000 hectares. 77% of these farmers planted maize on less than 1 hectare of land, so tiny portions of land. Only 3% farmed on greater than 100 hectares. Of this 3,500 farmers, we did a questionnaire survey of just over 300 farmers. And we found that they plant small areas of maize year-round, mainly for green maize, mainly for the roasted cob markets, the vendors. They sell to the vendors who roast these cobs on the street corners all over the rural areas and in the cities. So this is where the money is. Most planted open pollinated maize, but only one farmer had BT maize. In fact, the crop losses are difficult to estimate because to work out proper crop losses, you've got to spend an awful lot of time in the crop. But the estimates were from 25 to 100%. Many farmers had to replant more than once in the season, and this replanting caused a depletion of their resources, obviously. Many farmers relied totally on the province to provide inputs such as seed, the tractors for ploughing. They waited until the department comes and ploughs, and for pesticide handouts. Fall armyworm was financially crippling with direct impact on many homesteads and caused food security issues. The survey showed that most of these farmers had few skills or resources to plant alternative crops. They had to sell livestock and household goods to make money to survive when their crop was written off. Many had to seek employment on other farms or leave farming to go to work in the cities. The undeniable sort of forecast is that the fall armyworm pressure will force many farmers to give up farming entirely. And this is a severe worry. The commercial guys can spray if they've got the money, but the commercial cost of commercial spraying of pesticides is over 1,000 rand, up to 1,000 rands a hectare. So this isn't economically viable as well. They're protected at the moment by BT maize, but insecticide resistance is coming their way, I'm afraid. Other invasive pests, recent invasive pests, are the oriental fruit fly. We have at least 4 species of fruit fly from Asia in Africa now. And the oriental fruit fly was first reported in Kenya in about 2003. And then we could track it coming down on the major transport routes. And it arrived in South Africa in about 2010. This is highly polyphagous, And there's a major pest of everything from carrots to mangoes. This is a big problem in subtropical agriculture especially. Major pests for smallholder farmers. The commercial guys, again, are spraying and controlling at the moment, but the smallholder farmers interspersed between the commercial farms are now reservoirs for pest populations. In Africa, the yield loss of mango is between 40 and 90%. So this is a severe worry for us, for especially smallholder farmers, but again, the commercial guys must watch out for this thing. The Department of Agriculture, Jan Hendrik's group, and CropWatch and others are monitoring and the fruit fly densities and distribution and presence and absence. And the current control is through the male attraction and killing in traps. And you can see there what a bucket full of males we can soon catch. Here's some ARC workers putting up fruit traps in smallholder areas and working with the smallholder communities. Tuta absoluta. Oh, this is a problem and a half, this one. Tomato pinworm, first reported in Africa in about 2006 and arrived in South Africa in 2016. A major pest of tomato throughout Africa in tunnels and open fields. The commercial guys, again, are controlling, they're spraying with their spray regimes, they're keeping it out of the crops, but it is causing devastation for smallholder farmers. We're also worried about the buildup of insecticide resistance. This is in other countries, there's already tutas resistant to a whole range of pesticides. Here's the typical windowing effect of the symptoms on tomato. There's a larva, and different from the leaf miners, so it's quite characteristic. Potential damage of tuta, as I say, the commercial guys are managing to spray, but in smallholder farmers, we're having complete loss of crops in many farms. Here's 4 hectares that are completely wiped out. If this carries on, we think that the future viability of tomato production in smallholder areas is in serious doubt. They just cannot keep up with it. Management of tuta by smallholders is a big problem at the moment. There's a complete lack of scouting and early warning. There's incorrect application techniques. They're using obsolete pesticides. They're using home-made cocktails of pesticides. There's underdosing and overdosing. Complete lack of personal protection equipment, as can be seen here with this guy. This is an environmental hazard emergency going on. And the department is giving out, trying to give out information sheets, fact sheets, training, but there's an awful lot more work that needs to be done. So the future needs are increased. We must increase our technology transfer and training, get into these smallholder areas, make sure that they know what they're doing and they're safe. We must implement pest level action thresholds, when to spray, when not to spray, IPM strategies. And we've done some surveys, and there are native natural enemies out there which have potential for biocontrol. So we cannot continue to spray pesticides on tomato. It's not going to work. The conclusions are that migratory and invasive pests will continue to threaten food security in Africa. And you can talk to Jan Hendrik, and there's plenty of more pests on their way here. There's plenty of things out there that are coming into South Africa, or will come soon. The fall armyworm, tuta, and the oriental fruit fly are of particular concern for smallholder farmers at the moment, with the complete loss of food security in some cases and income. All farmers are having escalating input costs, commercial guys and the smallholders, to try and control these pests. And there's environmental damage from this increased pesticide application, as well as human toxicity and all the rest of it. Going with this, there's a threat of the buildup of insecticide resistance. This is critical. Unless we do something soon, these pests will become resistant to what we're spraying, and we're in trouble. Already farmers are having to switch production or go out of business. This is a problem. fact, to the locust monitoring and control in Southern Africa, I consider to be weak. We're still using the same strategies and tactics we used 50 years ago. Locusts are going to get out of hand, more expensive to control, more expensive to monitor, more expensive to locate. And the next plague is coming. So we need early warning and effective management systems. My ideas on management strategies for invasive pests is, first of all, phase one, we've got to know our enemy. We need early warning, awareness, and communication. As I mentioned, there's already good trap networks for early warning, Dillard, Cropwatch, ARC, others. There's training, monitoring, identification, data is being collected, but we need to expand that. Communication is vital. We need platforms for public awareness. But to establish and maintain these information networks takes time and resources. We need good communication to farmers. Is a pest coming their way? We need predictive models to monitor outbreaks, migration, damage potential. This all needs to be fed in and be available to farming communities. Over the short to medium term, we need to ensure that we have safe and effective insecticides available for these crops. A lot of agrochemical companies registered insecticides for fall armyworm, but that was on an emergency registration. Now we need them to get it properly registered, because now all these products are technically illegal for tutor as well. We need proper trials and proper registrations done. We need a list of approved insecticides and application methods. We need to train the agricultural extension officers, to get them really up to date. And training courses and information must be available to all farmers. All the commercial guys must be able to log on and find information. The socioeconomic assessments is a concern, and just our brief studies on fall armyworm showed that the impact was far worse than we thought. So we need to look at tutor and oriental fruit fly and other pests like that. While we're waiting for better methods, why don't we try cultural control, crop varieties, planting dates, conservation agriculture techniques, anything to give us a bit of a gap while we register new pesticides. And then we must target pest populations at the most vulnerable stages. For instance, we must go in and spray those fall armyworm overwintering refugia areas, because then hopefully we could stop the invasions from spreading out when the rains fall. Over the longer term, as I mentioned, pest management information must be readily available to all farmers. We need effective outbreak monitoring and early warning systems. We must evaluate our biocontrol and cultural control methods. We must then slot everything into a best practice IPM strategies for the management of these invasive pests. I'm particularly concerned about the environmental risk going on with all this insecticide spraying, so we need more EIAs on that. And then we can't just be spraying these things and kicking the can down the road for the next generation of farmers to pick up the trouble. We must look after our insecticide resistance management. Thank you. That's what I have to say. Thank you very much.